Recording is rolling. Welcome to Monday, April 18th. Hope you guys had a great 3-day Easter weekend. So here's what we're doing. We're gonna look at some May schedules, gonna review circuits with you guys, and then you guys remember this page from last week had some circuits on one side and then Kirchhoff tables and waterfall models on the other. Right? So I will give you guys the rest of class after I do these first few things. The rest of class to work on these with your teammates. And yeah, and then if you finish by the end of class, which you might, if you keep a good pace, then turn that to the gray tray and you'll get points. All right, so let's take a look at some May schedules. Here's the final exam schedule for seniors, so just for seniors. So here's what we're doing. Thursday, May 12th. It's going to start with the fourth period, and then, well, a few days after that. So of course, I'll get everybody the exam review before this, right? So that definitely seniors and also everybody else have time to do this. We're actually getting real close to the end of the school year. I mean, you guys know that. So in this class, here's what we're doing. We're taking this week to do some more electricity stuff. Want to go solidify some topics, throw in another lab, resistivity lab. And then next week, I will do with you guys statistics and quantum mechanics. And then we're going to go into the final exam review and maybe do some in-class projects, but that's about it. We're getting right near the end. Yeah. Another May schedule. You guys have probably seen this one in maybe your other classes. All these I posted on Google Classroom, by the way, including this one. So the first week and a half of May is going to be fun times. Here's what's going to happen. So first few days of May, you're going to have a 3-hour block class. Now, which class that is rotates depending on the day. So it's going to go period 1, period 2, period 3, period 7. Right, then we'll have a Friday schedule. And then the week after that, period 4 and period 6. So the only one where you will not have a 3-hour block class is your 5th period, but each of your other classes, you get that. So yeah, we'll make the most of that, but that's coming up. Okay. Also want to remind you guys, because a couple of you guys might have AP classes. Here's a new deal, another opportunity to study for AP exams. If you go to youtube.com/advanced placement, there are live reviews that start today. And so this is also in Google Classroom if you want to access the link there. Like, for example, physics, AP physics, I know starts at 5 o'clock, and then this runs for a couple of weeks, but you might have one of these other AP classes. So there you go, there's some schedules. All right, let's review circuits. Review circuits. All right, so from last week, let's do an example circuit here, and then I'll run with it. Right. What if I have, let's say 24 volts, and I'll call this guy 12 ohms. Let's go 1 ohm, 2 ohms, and 3 ohms. Right? Okay, so the side that just says circuits on it, right? This one here. Here's remember what we've done so far. We did the top 8 circuits, right? And then we did these 2 circuits here. Now there's a pair of questions for each of these. Is what is the equivalent resistance from the point of view of the battery? And the follow-up question is, if I give you the voltage, what is the current flowing through this, right? So I'll do a really similar example right here. Right. Hey guys, again? Yeah, okay. Right. Remind you guys how to solve these. So first thing I need to do is to solve for equivalent resistance. So this 24 volt battery here is pushing against some total resistance. How much? Well, what you do is fly over to the opposite side of the circuit, as far away as you can get from the voltage source, and start finding equivalent resistances and work your way back towards the voltage source and set up equivalent circuits. So first thing I see is these 3 guys are all in series. You guys see that? Series. So just add them up, point, add them up. Okay, and then I'll redraw the circuit. So the fact that these 3 are in series, 1 plus 2 plus 3 is 6. Redraw the circuit. My voltage source still here, haven't touched that yet. This 12 ohm resistor still here, haven't touched that yet. But 1 plus 2 plus 3 makes 6. Right? Then work my way back towards the voltage source. These 2 guys now, do you guys see how this is equivalent to this? You see it? Yeah. Right. Okay. Now these 2 guys are in what, series or parallel? Parallel. So can I just add them up? No, I have to treat it like two guys painting a fence, right? Like, how about this? It takes this guy 12 hours to paint a fence by himself. This guy 6 hours to paint a fence by himself. They get together, make a 2-man team. Do you think they could knock out the job in, do you think probably about 4 hours? Does that sound about right? Right. But what's the actual math behind that? Do you do product over sum? Right? So the equivalent resistance is 12 times 6 over 12 plus 6. Right? As long as you have 2 at a time. There's also that fraction method if you have more than 2. Here, there's posters hanging from my ceiling up here. You guys see these posters? Right. Just navigate those. They'll tell you resistors and series of parallel. Here we got parallel. So that's 72. Those would be ohms, right? Divided by 18. Hey, that is 4. Look at that. That's 4 ohms. Remember we were saying like painting a fence, it should take like 4 hours, 2-man team to knock out the job. Right? 4 ohms, 4 ohms total resistance. Right? You guys see that? Right. Now the follow-up question is going to be how much current is flowing from the battery? Because I told you 24-volt battery for this made up example. Okay, you guys got 4 ohms equivalent resistance. Yeah. So let's kick over to Ohm's law. You guys remember Ohm's law? It says that the current that flows is equal to voltage divided by resistance. Right? I stands for current, right? Current. V, or sometimes delta V, like potential difference, right? So we're looking at I've got 24 volts acting on 4 ohms of resistance. Hey, is that called like 6 amps? You guys see 6 amps? Right, you guys see that? Remember all this from last week? Right. Right. Then if you want to go a step deeper, and this is here's what I'm getting at. Okay. If you flip the page over, look at these Kirchhoff tables and the waterfall models on the back. We dig into the circuit and say, well, how exactly does the current flow through each resistor, and what is the voltage drop across each resistor? Right. So it might look actually it would look a lot like this one, wouldn't it? Right? I'm kind of helping you guys out here. Right? So how about this? You guys remember the loop rule says if I got 24 volts up, you have to drop down 24 volts here. You guys remember that? Actually, let me break out Kirchhoff's rules again. Remind you guys of this. So if you see resistors in series like this, the current's the same everywhere, right? Current's the same everywhere. The voltage drops down a little bit at a time. It drops down proportional to each resistor. So for example, if this is 3 ohms and 7 ohms, you got like 100 volt difference, then it would drop 30 volts over the 3 ohm guy, and it would drop the other 70 volts over the 7 ohm guy, just proportionally to resistor. That's exactly what this says. Okay? Switch over to look at parallel. Now parallel, the voltage drop has to be the same. This would be like side-by-side waterfalls in the waterfall model, right? That doesn't mean the current's the same. Doesn't mean the resistance is the same, but the voltage drop is the same. It might be 1 ohm and 99 ohms. It's still the same voltage drop, okay? But the current splits. Now remember, the current wants to follow the path of least resistance. So again, if it's like 1 ohm versus 99 ohms, I bet 99% of the current goes through 1 ohm and only 1% of the current goes through 99 ohms, right? That's what this says right here, okay? The current is proportional to the other resistor. Right? Okay. You guys remember all that from last week? Okay. It's all in your notes. Right. So for this one here, do you guys see 24 volts up and 24 volts down? Right. So there's a 24 volt drop across this guy. Now there's also 24 volts drop collectively across these 3, but a little bit at a time because these 3 guys are in series. So do you guys see how this is 1/6 of the total drop? Guys, what's 1/6 of 24? That'd be 4 volts, right? You see 4 volts drop there. Ooh, this is double that. So you think 8 volts drop here, and this is triple the original. So do you think 12 volts drop here? And what is 4 plus 8 plus 12? It adds up to 24. Right? You guys see that? Loop roll. Right? All right. So that's reminding how to do these. So you guys got the rest of class to do this. Do these 4 circuits, both equivalent resistance and current flowing through the battery. Right? For these 4 that we didn't do last week. And also do these 2 waterfall models. Now for the rest of class, I will leave up the answer key for my own. I have unique numbers. Nobody has exactly my numbers, but this is what my waterfall models look like themselves. Right. If you guys finish by the end of class, pop in the grade tray and you're good to go. If you don't quite finish, then just get this in the next couple of days, because then we're going to start grading these and putting points in the grade book. And there's some interim report that closes out this Friday too. Okay, so yeah, if you have any questions, let me know, but you guys got the rest of the class.